Okay, everybody, let's continue with our basic algebra review. Now, in the next section, we're going to deal with properties of exponents. So before I go any further, let me show you a summary of exponents right here. I'm going to upload this paper as well. So we have what we call product of powers, which is when you multiply two quantities that have the same base, you add the exponents. If you have a situation like this where you have an exponent inside and an exponent outside, you multiply them. If you have more than one quantity that is being multiplied inside with an exponent outside the parentheses, you can distribute the exponent inside, but that's only when you have a multiplication, not addition or subtraction. If you have a negative exponent, we always get rid of negative exponents in algebra. If you have a negative exponent on the top, you flip it to the bottom, you see, negative m became positive m. The whole thing goes to the bottom and the exponent becomes positive. If you have a negative exponent in the bottom of a fraction, you move it to the top and the exponent becomes positive. Anything to the power of 0 is 1. Anything to the power of 0 is 1, doesn't matter what it is. If you have a fraction where the bases are the same, you subtract the exponents. So remember, multiplying, if the bases are the same, you add the exponent. Dividing, which is a fraction, you subtract the exponents. And then if you have a fraction with the exponent outside, you can distribute that exponent to top and bottom. And if you have a fraction with a negative exponent, if you flip the fraction, then the exponent becomes positive. So let's keep these in mind. Again, I will upload this paper in so you guys can have access to it. Let's do this. So we take care of these exponents first. We don't multiply the 6, so it will be 6. Now notice the power on x is 1. So if the power is not shown, it's automatically 1. So 1 times 5, you get x to the 5th. And then 3 times 5, you get y to the 15th. That's it. You can't do anything else. Let me focus a little bit. Okay, there we go. Here, you multiply the exponent again, so you get x, negative 3 times negative 2, that's positive 6, x to the 6th. And then you have positive 2 times negative 2, that's y to the negative 4. All right, now remember, as I said, we always get rid of our negative exponents. Now, x doesn't have a negative exponent, but y does. So this whole thing goes to the denominator. So you're going to get x to the 6th, y to the 4th. Following this, you see, if you have a negative exponent, what do? We take it to the bottom. There we go. Okay. Let's move on to number 9. Well, let's see, it's a fraction, so that means division. 9 divided by 3 is 3. And there are two ways of approaching this. You can just, you see the u's have the same base. So we can subtract the exponent, or since this has a negative exponent, you can take it to the bottom first. So let's do that. So we can have u to the 4th, which is stays in the bottom. This u to the negative 8, I'm going to take it to the bottom, and the negative 8 becomes positive 8. Okay, now the v's again have the same base, so you can just subtract the exponents. So do we have more v's on the top or on the bottom? We have more v's on the top. So basically what you're doing is 9 minus 8. Okay, subtract the exponent. Again, based on this rule, remember, if you have the exponent, you subtract them if you're dividing. Okay, so let's simplify this. So we have 3v to the power of 1, which we don't have to show because 9 minus 8, over u to the power of 12. These are being multiplied, so you add the exponent, and that's it. You can't do anything else. All right, let's move on to this one. What's anything to the power of 0? That's 1. What's 3 to the second power? That doesn't mean 3 times 2. That means 3 times 3. 3 times itself. That's 9. Now, you see this has a negative exponent. You can take it to the bottom. This has a negative exponent. Take it to the top. So that's plus 2 squared over 3 squared. So we have 1/9 plus, what's 2 squared? That's 2 times 2, 4. What's 3 squared? 3 times 3, 9. So have the same, these fractions have the same denominator, keep the same denominator, add the exponents, add the numerators, and there we go. Are we good? Let's look at the backside. Oh yes, there is a backside. Okay, so so factoring is the reverse of the multiplication process of binomial. So basically, what do? We put 2 parentheses, and we say, how do I get t squared? So definitely I should have had t and t. Okay. Now, before I go any further, let me give you a little table of signs for factoring, so that will help you. Okay, so if you have a polynomial, and you want to factor it, if you have 2 pluses in the polynomial, then you put 2 pluses in the parentheses. If you have a minus first and a plus, then you put minus, minus. If you have a plus and a minus, you put plus and a minus. And if you have 2 minuses, again, plus and a minus. And these two could be a minus and a plus, doesn't matter. Okay, so write that down because it will help you. So this one you have minus and a minus, so you put, let's put a, so minus and a minus, I'm going to put a plus and a minus, so plus and a minus. Now I look at the factors of the last number. What are the factors of 6? You can have 3 times 2, or you can have 6 times 1. Okay, so which one of these can give you 4? Neither of them. Because if I put a 3 and a 2, that gives me a -6, but when I do the middle, that's 3t, and the outer, that's -2t, that's not going to give me -4t. And if I put the 6 and a 1, that's not going to give me. So this is not factorable. Or we call it prime. A prime polynomial means not factorable. That's it. Sometimes you might see those. All right, let's look at this one. Now, anytime you're factoring any polynomial, you look for GCF, greatest common factor, a factor that is common to all the terms. Sometimes you have it, sometimes you don't. In the previous one, there was nothing in common between these 3 terms. But if you look at this one, we do have something in common. What's common between 6, 9, and 15? A 3. So I can take out a 3 from all of these. I have 3 n's, 2 n's, and 1 n. What's common to all of those n's? 1 n. So I can take out 1 n. So then what's left? 6 divided by 3 is a 2. I have 3 n's. I took out 1, so I'm left with 2. 9 divided by 3 is 3. I had 2 n's. I took out 1. 15 divided by 3 is 5, and it's a negative. And I had 1 n, I took out 1 n, so that's it. Now so I took out the greatest common factor, or the GCF. Now I'm going to leave that on the outside. I'm going to start factoring that. How do I get n squared? So I should have had an n and an n. What are the factors? Now, if you see in this previous problem, the coefficient in the front was 1, so I don't have to worry about it. But here, the coefficient is not 1. So what are the factors of 2? So you got 2 times 1. That's it. So I'm going to put a 2 and a 1. You don't have to show the 1. 2 minuses. Remember, 2 minuses, what do we put? Plus and a minus. Now we might have to switch the signs. Then you look at the factors of the last number. What are the factors of 5? It's a prime number like 2, so it's just 5 and 1. So I'm going to put the 5 here and a 1 there, see if it works. How do you check it? You multiply the ones that are farthest apart, that's negative 2n. You multiply the ones that are closest to each other, that's 5n. Do I get the negative 3n? 5n minus 2n, I get a positive 3n. So I got the 3, but the sign is wrong. So I'm going to switch the sign. So that's a plus. I'm going to make that a minus. So the answer is 3n times 2n minus 5 times n plus 1. Okay. All right, so we're going to stop right here and pick it up in the next video.